So last week we had talked about SailCo, and we said that there could be two different models. And in the first model, we had used XT, YT, and IT, and of course DT for the demand, but still XT and YT were our decision variables. IT, the inventory levels, was calculated from XT and YT and DT, of course. DT was our parameter, and IT was just calculated by using this loop over here. Now, here, if you take a look at this constraints, how many rows of constraints do I have here actually? I'm just writing one row here for this constraint, but in reality, how many constraints do I have here for this, just this one, this inventory constraints? How many rows do I have here? You'll know the answer because you know the problem, but if you need to remember it, take a look here. How many rows of inventory constraints do I have here? Okay, how many quarters do I have for the problem?
4.
4. So I should have 4 demands, which means that I will probably have 4 constraints at least, because I will have 4 demand values. Now, you can think of other stuff. Maybe there's a 5th, demand, or which we don't know. So there can be a 5th period actually, but still, we don't need to know about that one yet. But when you take a look over here, we know that there is a starting inventory of 10 saleables, which is actually I0, okay? Because we know that this is IT's saleables on hand at the end of quarter T. We had talked about this one last week, if you remember. It can be at the end of a quarter or at the beginning of a quarter, but still it's the same thing, okay? The end of January is the beginning of February. They are the same stuff, but it just changes the T value. So in here, I already have the value I0. I know about it, which means that I will be finding I1, which means I'm going to use D1. So up to D4, which will give me I4, the end of period 4, the event at end of period 4. So I actually have 4 constraints here. All right. What about here? XT is less than 40. How many constraints do I have here? How many XTs do I have?
4 again, I guess.
4 again, yes. And I have the sign restrictions. These are each 4, so 12 sign restrictions here. But still, here, if you disregard the sign restriction, it's not important. I have 8 constraints over here. Okay, you can just see the how large the model is by counting the number of constraints. Okay, and of course you need to know the number of decision variables, but still number of constraints gives you a better picture at least here. And I have the objective function here, of course. Now, I said that there's a second way to model this one. Now, the second way comes from picking decision variables in a different way, actually. Now, do you have any idea how we could have picked the decision variables? What kind of a change could we make with the decision variables? Any idea at all? I don't need to see the right thing right away, but still, any idea how we can change the decision variables instead of XT and YT and maybe IT? What could we use? No ideas, right? Okay, that's normal, by the way. It's not, it's nothing to be, it's nothing to worry about. But still, you could have used, and we will use actually, indices for the X variables. Now, I will just name the index I, J, and K. Now, this X, I, J, K is going to be my one and only decision variables. But still, it depends on I, J, and K indices, where I is the quarter to sell, okay? Produced in quarter I is the production time. To sell in quarter J is the selling time. Using labor type K is my labor type. So I'm going to produce in quarter I. So if this I is 1, then I'm producing in quarter 1. To sell in quarter J, if J is 1, then I'm selling in quarter 1 as well. Using labor type K. Now, labor type can be normal or overtime. So if I'm using normal production, then it's 1, K is going to be 1. By the way, we are naming it the way we want it. We can change that one as well, but still easier to name it one. Or you could just say, okay, let's leave it as 0. K is 0, it's normal time. K is 1 is overtime. Or in here, K is 1 is normal time. K is 2 is overtime. But it's all up to you. So in here, these indices, I, J, and K, will define what we are doing, okay? For example, if I say I is 1 and J is 2, it means that I'm producing in the first period, I'm keeping it in inventory for one period, and then I'm selling it in the second one. Okay, I is 1, J is 2. If I is 2 and J is 4, it says that I'm producing in the second quarter, second demand time, but I'm going to sell it in the fourth one. I'm keeping it in inventory for 2 periods or something like that. Now, this one has actually a small advantage, but it's a significant advantage, which is not relevant to this question right now. But if the question was a bit changed, it will be extremely relevant, which is we can actually sell stuff with a backlog, which means that we could just produce in the second quarter to sell in the first quarter. Now, this doesn't mean that we have a time machine. We are not going back to sell it. We are just producing it late. Okay, we are going to pay a lateness fee, which is not relevant here because it's not allowed in this question. But in the general sense, it might be allowed. There's a very frequent example for this. We just keep seeing stuff like this. We can send it late. Okay, lateness is permitted with a penalty most of the time. Here, lateness is not permitted, so we cannot do it. But in the first model, it would be impossible to sell with a backlog. Okay, we couldn't sell in the first period what we have produced in the second period. It wouldn't be allowed. But here, now we can do it. As we can just pick I as 2 and J as 1, it will mean that we are producing in the second period to sell in the first one. I know this is a bit confusing, but bear with me. You will understand what I'm talking about later on. And with this type of decision variable, our constraints would be a bit different as well. Now, think about it. In the first one, the demand constraint, well, it's just here with the inventory constraint. The demand is met with the inventory constraint. We don't care about it. But in here, we have to think about the demand constraint all by itself because we don't really have an inventory, variable here. We are not using an inventory variable. We don't need it right now. We can just, think of something. It's easy, but we don't need it. So to make the model smaller, we are just disregarding the I values. You will see what I'm talking about in the objective function at least. But think about it like this. We have the demand, dj. Okay, this is the demand in the jth period, the period that we are trying to sell the stuff. So dj, the j period, should be a sum of all i's and k's. Now, when you have indices with a decision variable, if you sum at least one or maybe two indices, whatever you are not summing will be the number of constraints you have. So if I'm summing all the i's and k's, I will have j values, and all the j values will have a row by itself. Okay. For example, in here it says for all j. So j can be 1, 2, 3, and 4 when I'm selling this one. Okay. If it's 1, I'm talking about the first period, first quarter where I'm trying to sell stuff. If it's 2, the second quarter, etc. So in here, I'm trying to find the number of sailboats I have manufactured or produced or whatever to be able to sell in a specific demand demand quarter. So for D1, for example, think of it. Let's go back all the way back to the question. For the first period, I have to take into account the number of inventory I have plus the number of sailboats I'm going to produce in the first quarter, right? But I can also produce in the second, third, or fourth quarter as well if I want to, and sell them by going back. So I have to write for all I and k. Now in here, I can say I is less than or equal to j. Now that's something I can do for this question because in this question it says that you have to produce before you can sell. Okay, but this is the more general version. I can be greater than j. But for this question, only just this question, I have to write I is less than or equal to j, because I know that I have to produce before I can sell for the specific question. Okay, so there should be a value of I is less than or equal to j over here somewhere. It's omitted, but you have to write it. So I will probably correct it later on. But still, I is less than or equal to j, because I have to produce before I can sell for this specific question. It's not always like that, but for this specific question, I have to do that. And what about the production limit? Well, I already know that I have a limit of 40 for normal time production, which was k is equal to 1. So for k is equal to 1, it doesn't matter which part I'm trying to sell for. The production date is important. The production period is important, which is I. So I'm just gonna find for all I values the sum of all j for the first type of production. Okay, labor type 1. So this sum is going to be less than or equal to 40. Think about it. Let's just try to write this, annotate this, and you will see soon enough. Now, let me just take this here and write it. For example, let's just do it for I is equal to 1. Okay, let's start writing for I is equal to 1. Now, when I is equal to 1, we have x1, 1 plus x1, 2, 1 plus x1, 3, 1 plus x1, 4, 1. Now, when you think about this one, let me just get it bigger and bigger, which is going to be less than or equal to 40. Let me just, yeah, that's better. Now, when you take a look at over here, okay, in this one, you can see that it's all for I is equal to 1, okay? x1, x1, x1, x1. And we are summing all the j values, 1, 2, 3, 4, when k is equal to 1. 1, 1, 1, 1. Now, this is for I is equal to 1. It says that, okay, take the summation for the production period is 1, the demand is for 1, and the labor type is 1. Production 1, demand is for second period, and production type 1. The production time is 1, the demand is for the third period, and the production type is 1. The production time is 1, the demand is for the fourth period, and the production type is 1. This total cannot be greater than 40. Why? Because we are talking about producing stuff in the first quarter. That's just for the first quarter. Okay, this makes the constraints a bit more, complex, yes, but it generalizes the question. Okay, both of the methods are acceptable. Both of them are correct. There is nothing wrong with both of them. One of them is more complex for a more general, model for more general, let's say, question. The other one is just specific to that question and easier to implement, but both of them are correct. Okay, you can find other modeling types maybe as well, but as long as it's logical, it's stable, it's okay. So this is the production limit, and then we have the sign constraint, of course. Now, when you take a look over here, we already know that if, for example, I say this one for the second period. Now, let's just try to make this one for the second period. x2 to 1 plus x2, 3, 1 plus x2, 4, 1 is less than or equal to 40. Yeah, now let's take a look at the second period then. Now, when I take a look at the second period, I already know that this value is going to be 0 because I cannot produce in the second period for period 1. Okay, this is lateness. Lateness is not allowed in this problem, so this value is going to be 0. So I can just write the same thing over here as well. I should be less than or equal to j. Okay, because it's not allowed. All these values have to be 0. Or I can just say that all xij is equal to 0 if I is greater than j. That's another constraint I can write. Instead of writing the indices with a limit, I can just write another constraint and I can just limit these values to 0 as well. It's possible. I can go both ways, or maybe devise another one. It's all about being creative to find a new way of showing stuff, this modeling thing. And over here, these values are all equal to 0 or greater than 0. They can be greater than 0, but the total cannot be greater than 40 because the number of sailboats I can produce in the second period. This is the production period, as you can remember. The second period with normal time is at most 40. So I can write these like that one. If I take a look over here, it's for all j, for all I. Again, here, 4 constraints, and here, 4 constraints, 8 constraints again. But the objective function is a bit different now. Now, if you take a look at the objective function, over here, I'm summing every value where I'm producing with normal time and just multiplying this by 400. Now, actually in here, I have 16 different decision variables instead of the 4 decision variables in the model before over here, like this one. And in here again, 16. Of course, I know some of these are 0, some of these are 0, like I don't know, 1, 2, 3, 3 of them, I guess. So a total of 6 variables are 0 over here, and another 6 0 over here. But still, I have a lot of variables in my objective function instead of the just 4 plus 4, 8 ones over here and the i's over here. But still, they are the same decision variables. These over here xij's and these over here xij's, but still these are for xij1, these are for xij2. And over here, I have to find the inventory cost. Now, if you take a look at this one, over here, I is less than or equal to j. We have put this limit to the objective function. I is always less than j. So this goes for every value in every constraint. So it's settled over here. I didn't need to write it over here. I've just written it over here. I is less than or equal to j. I'm just looking at these values. But I have to, of course, show it over here as well. But over here, I know I'm talking about all i's that are less than or equal to j. Now, when you take a look over here, actually, this one is a bit, more confusing because it's going down a row, but still, 20 times j minus I. Now, j minus I gives you the difference between the production time, which is I, and the selling time, which is j. If you are keeping something in inventory, it's for j minus I periods. For example, if j is equal to 2 and I is equal to 2, you're not keeping inventory. You're just building in the second period and selling in the second period. But if you are building in the second period, producing in the second period, and selling in the third, then I is 2 and j is 3, and the difference is 1. You are keeping it in inventory for 1 period, which means that you will have to pay $20 for that inventory. Again, over here, we have all ijk. We are just summing everything over here to see what we are going to, use. So for all ij, you are going to have to use that one. Okay, this is your inventory cost automatically. Now, again, all I is less than or equal to j. Doesn't really change that. Because if I was greater than j, then you would get a negative value over here, and it would be, okay, what am I doing here? So this one, if back cells were allowed, this limit would have to be transferred over here. I would have to put a penalty value over here to show when j is less than I, when the selling period is earlier than the production period, you would have to use a penalty function over here as well, and a penalty, summation value over here. And then you would write j is less than I for that one. But here, we only can use I is less than or equal to j, because we cannot, sell with a backlog. It doesn't really allow it to do that. All right? Now, let's take a look over another problem. This one is a bit, again, different, but it's not that hard. Not as hard as the sailboat second model, at least I would say, but we'll see. At the beginning of January, 50 skilled technicians work for CSL. There's a company called CSL, and it has 50 technicians. Each skilled technician can work up to 160 hours per month. All right. To meet future demands, new technicians must be trained. Okay, now we have gotten 3 different bits of information here. We have 50 technicians, which is a parameter. All right. Each technician can work after 160 hours, and a parameter. All right. And we have demand, future demands. New technicians must be trained. We are going to train someone. All right. This is not really clear yet how we will gonna apply it, but still there's some information over there. It takes 1 month to train a new technician. Okay, so we can hire someone new, train him for 1 month, and then start using them. All right. New technicians must be trained. It takes 1 month to train a new technician. During the month of training, a trainee must be supervised for 50 hours by an experienced technician. Now, we have technicians and we can devote their time to supervise a new technician as well. All right. Each experienced technician is paid $2,000 a month. Nice. Even if he or she does not work the full 160 hours, of course, it's wage anyway. And during the month of training, a trainee is paid $1,000 a month. Okay, we are still paying our trainees, which is good. At the end of each month, 5% of CSL's experienced technicians quit to join Plum Computers. Okay, we are losing blood at the end of the month, so we are losing technicians, so we have to replace them as well. Formulate an LP whose solution will enable CSL to minimize the labor costs incurred in meeting the service requirements, which is demand, given in the table below for the next 5 months. So we are trying to find or formulate our human resources. Okay, how many new technicians are we going to hire? How are we going to train them, and how we can meet the demand? That's what we need. So we have to find our decision variables. We have to find our objective function and our constraints. Let's start with the simple stuff. What are our decision variables or our parameters? Doesn't really matter. It can be a decision variable, can be a parameter as well. It might be dependent on another decision variable as well, like the inventory number we have seen in the sale code. What are our variables, decision variables or otherwise? What are our variables? Some are very easy to say. Can you give me anything?
Can we say the number of experienced technicians?
Okay, number of experienced technicians at the start of a demand time, let's say. Yes, number of experienced technicians can be a variable because it's not really a decision variable, but it's a decision variable as well. You will see what I'm talking about. But yes, it's a very good variable. Number of experienced technicians we have. What else? You can give me a parameter as well. We have parameters over here as well. It's very obvious. Like these guys. What are these? These are the, come on, these are what?
Parameters.
The demand, right? These are the demands. These are parameters. D1 is 6,000, D2 is 700, D3 is 8,000, sorry, not 100, and stuff like that. So these are the demands, D1, D2, D3, D4, D5. Okay, these are variables as well, though. We can just name them as variables as well, but they are parameters. We know all of them. So what else? At least one more thing.
Cost of labors, cost of technicians, actually.
Cost of technicians, again, parameters or, we can say coefficients over there. Okay, what else? We are missing the key ingredient here.
Teknisyenlerin trainee'leri yetiştirecekleri saati belirlemek için bir variable.
Okay, ama onu için fonksiyon içerisine çıkartacağız. We still need one more variable. Okay, we have the number of experienced technicians, we have the monthly demands, and we need something, the key, the most important thing. Think about it.
Newcomers.
What?
Newcomers olur mu?
New?
Şu yetiştiler, experience oldular bir ay sonunda.
Okay, new technicians, the newbies. Number of new technicians we are going to hire. This is the key. This is the linchpin, okay? They will, why? Because the number of new technicians we hire will give us the number of experienced technicians for the next month, okay? You can just think about it like a production, okay? We are producing technicians over here. The number of new technicians we hire will affect the number of experienced technicians we have the next month. All right, so we have the number of technicians trained higher than trained in that month. We have the number of experienced technicians, and we have the demand. Using this, we can formulate our, model. Now, let's just think about it, how we can do this. Now, we already know, let's say that number of technicians hired is XT. Okay, let's just start with that one. XT, number hired. Okay, YT, number experience. Okay, this is taken. And we have DT, demand. Now, using these three, we can formulate our, loops. For example, think about this one. this is the number of hired and this is the number of experienced. We are talking about the first month. In the first month, we have 50 technicians, right? Okay. How many technicians do I have in the second month? Give me the number of technicians in the second month. Number of experienced technicians in the second month. So I know that Y1 is 50. Give me Y2. How can I find Y2? Y2 is equal to what?
Is it 50 plus x1?
Sorry, come again?
Is it 50 plus x1?
No, it's not. It's not 50
A-
plus X1.
I
X1 plus 95% of Y1.
Yes, 0.95 times Y1 plus X1, exactly. Why? Because we are losing 5% of our experienced technicians at the end of the first month, so they are gone. But we are getting new technicians experience, so they are coming in. So Y2 is equal to this one. So we can just write this, instead of writing this, of course, we are going to use YT plus 1 is equal to 0.95 YT plus XT. Now, this is the general version for all T's, okay? For T is equal to 1 or T is equal to 2, etc. But these two things are the same. This is just a general version for all demand times, okay? For all periods or months, whatever. Now, we can write this one as our available technicians constraint, okay? This is the number of technicians we have for the T plus first period, all right? This is always true. This always holds. For T is equal to 1, this is 50. We know this. Okay? Y1 is 50. We know this one. This is in the back. But for all other periods, we're going to use this to find what we are doing. All right. This is the number of technicians constraint. All right. What about the demand constraint? We have to, come up with a solution that meets the demands. How can I find a constraint for the demand? Let's start with the first, month. How am I going to fit the time of my technicians into 6,000 hours? What's the formulation? How can I do this? How many technicians do I have in the first month? Skilled technicians. 50, right?
Y1.
50. How many each one of them has? How many hours each one of them have?
160.
160. So my total number of hours is 6,000 for the first month, right? 6,000 hours. Pretty good. So using those 6,000 hours, I have to find a way to deliver 6,000 hours. It's easy, but how? Now, think about it like this. I have 160 times 50. This is the number of hours I have available, okay? I have to fit 6,000 in there for the first period. I have to fit something more. I need something else here. What else?
Çarpı 50 eksi hani teknisyenlerimin diğer newbie'leri çalıştırmak için ayıracakları
Okay, training hours.
training hours, evet.
50 times 50 hours, right? Yes, 50 hours in experience. So 50 times x1. So this one should be greater than or equal to this plus this, okay? 6,000 plus this should be greater than or equal to this one. But this is just for first month. I have to generalize this one as well. So to generalize it, I have to find a better, way of writing this. So I can just say that for any period, I have 160 hours per what? Experienced technician, which is the Y value, YT. All right. If I have YT, then I have to subtract 50 times XT from it. Why? Because I'm going to train XT number of new technicians, which still should be greater than or equal to, equal or greater than or equal to, doesn't really matter how I write it, but still greater than or equal to my demand for that period. It's something like this one, okay? It's not very clear here, but still, let's just go to the next page and you will see what I'm talking about over here. The demand constraint. Now, think about it. This is the available technicians because for each period, I'm going to have to train someone from beforehand and I'm going to lose 5% of whatever I had the period before, and it's going to be my current number of technicians for T plus 1. And I'm starting with 50 technicians, it's written here. And this is my demand constraint. Now, with my demand constraint, I already know that there's a demand around the demand, it doesn't really matter. It has to be met, so it's greater than or equal to. And there's a number of experienced technicians, which is YT for that period, times all their available hours, 160, minus teaching time. Okay, I'm teaching for 50 hours for each new technician. So using 50 hours for each new technician. So this is gonna be my demand constraint. Now, from here, I can solve whatever I need. So what I need is the objective function, which is to minimize my costs. Okay, I'm trying to minimize my costs. So if you take a look over here, let's go back. My costs are my wages, paying 1,000 per month to newbies and 2,000 per month to pros, okay, experienced technicians. So these are all the newbies and these are all the experienced technicians. I'm just trying to minimize this waging, okay, this salary total. So it's actually, if you can, formulate it after thinking of it, it's not that complex or that hard, at least when compared to sale code. The most complex part is over here and over here, okay? The demand constraint and the technician constraint. These two are to work on, but number of star technicians is easy and the objective function is easy as well when compared to these two constraints. So you have to focus on these constraints to understand what we are talking about. All right, what about another problem? The oil blending problem. Now, oil blending is actually a very, let's say, let me just, how do I hide this one? Yeah, this one, yes. Now, when you take a look over here, oil blending is actually a very common problem. It's not just oil blending, but blending problems all over, but still oil blending is the most common one you will see in this course anyway. There is a raw material, and using that raw material, you blend those raw materials to come up with a product, and then you sell that product. Okay, so we have, let's see what we have. Sanco Oil manufactures 3 types of gasoline. So gas 1, gas 2, and gas 3. These are our products. We are selling those gases. As you can see, there is a let's see, sales price, yeah, for barrels for gas. Okay, each gas is sold, and there's a crude oil purchased. So we are purchasing oil, turning it into gas and selling it. All right. Each type is produced by blending 3 types of crude oil, crude 1, crude 2, crude 3. The sales price per barrel of gasoline and the purchase price per barrel of crude oil are given in the first table over here. Sanco can purchase up to 5,000 barrels of each type of crude oil daily. Okay, we have a limit of how much oil we can buy, 5,000 at most. Okay. And then some 3 types of gasoline differ in their octane rating and sulfur content. So each gas have a different quality to it, which comes from octane rating and sulfur content. For example, it's I think given over there. The crude oil blended to form gas 1 must have an average octane rating of at least 10. All right, and contain at most 1% sulfur. So it should be the most quality one, I think, most highest quality one, I think. We'll see. The crude oil blend to form gas 2 must have an average octane rating of at least 8 and contain at most 2% sulfur. Most sulfur, lower octane, so lower quality, I would say. Not really sure. The crude oil blended to form gas 3 must have an octane rating of at least 6 and contain at most 1% sulfur. The octane rating and the sulfur content of the 3 types of oil are given in the second table. It costs $4 to transform 1 barrel of oil into 1 barrel of gasoline. So we have a production cost here as well. And Sanco's refinery can produce up to 14,000 barrels of gasoline daily. Okay, so we are getting crude oil turning into gasoline, but we can do at most 14,000 barrels per day. Sanco's customers require the following amounts of each gasoline. Gas 1 is 3,000 barrels, gas 2 is 2,000 barrels, and gas 3 is 1,000 barrels per day. The company considers it an obligation to meet these demands. So we have to meet the demands. We cannot just, fall short of it. Each dollar spent daily in advertising a particular type of gas increases the daily demand for that type of gas by 10 barrels. Oh, okay. We can advertise and increase our demand. Nice. For example, if Sanko decides to spend $20 daily in advertising gas 2, then the daily demand for gas 2 will increase by 200 barrels. 20 times 10 is equal to 200 barrels. Formulate an LP that will enable Sanko to maximize daily profits. Okay, profits is revenues minus costs. They are missing some operators over here, but still we know what they are. So we have to model this problem, and this is not an easy problem. This is a big problem. Okay, it has lots of things to think about, and it's actually very hard. It's not that easy to come up with a solution. But still, we have to start somewhere. But starting somewhere is easy. We have to pick the decision variables. So what are my decision variables? Hint, think of the SailCo second model. Okay, we need indices over here. If you don't use indices, you're gonna be extremely confused, and it will get extremely complex very hard, very fast. So you have to think with indices over here. What are my decision variables? What kind of decision variables can I have here?
Hocam soruda anlamadığım bir şey var. Sorabilir miyim?
Tabii ki sor, buyur.
Soruda şeyleri veriyor ya, sorunun içinde işte gaz 1'in octane ratingi 10 olmalı, işte
Evet, evet.
Daha üstteki tabloda daha farklı değerler var. Onun nedeni
Bunlar crude oil. Bakın şimdi benzin yapıyoruz petrolden, tamam mı? Crude dediğimiz şey crude oil, petrol. Gaz dediğimiz şey de benzin, gazolin aslında. Petrolden benzin yapıyoruz. Petrol değerleri bunlar. Petrolün değerleri. Mesela 2 varil petrol karıştırıyorsun. 1 varil gaz petrol 1 varil petrol 2 karıştırıyorsun. Tamam, bu karışımdan sen 12 artı 6, 18 bölü 2, 9 oktanlık benzin elde edersin diyor. Mesela. Bunlar işleniyor tabii. Karıştırılıp böyle hemen benzin olmuyor ama karıştırıp işlendiği anda 9 oktanlık benzin olur diyor mesela. İşte sulfur content burada verilmiş mesela. 2 ile 3'ü karıştırdığını düşün. Petrol 2, petrol 3'ü karıştırdın. 2,5 sulfur contentin olmuş oluyor. %2,5'a ulaşmış oluyorsun mesela. Bunları kullanaraktan şu aşağıda verilen oranlarda benzin elde etmeni istiyor senden. Yaptığı şey bu. Yani sen buradan bir karışım yapıyorsun. Zaten blending karışım. Bu yaptığın karışımla şuradaki petrolleri karıştıraraktan yaptığın karışımdan bir benzin elde etmeni istiyor senden. Ve bu benzin ne için? 3 tip benzin olacak diyor. Bu 3 tip benzin de şu şeyleri sağlaması lazım. Özellikle sağlaması lazım diyor. Dediğim gibi mesela 1, 2, 3'ün 3'ünü aynı anda karıştırdığınızı varsayın. İşte 12 artı 6 artı 8 ne oldu? 26 oktan. 26 bölü 3'ten işte 8,66 oldu mesela. 8,66 oktanlık bir benzin elde edebilirsin. Üçünde birer varil karıştırırsan. Üçünde 0,33 varil karıştırırsan 1 varillik benzin elde ediyorsun. Fark etmiyor. Ama sonuçta karışımların oranları bu şeylerin, oktan ve sülfürlerin şeylerini çıkartıyor, değerlerini çıkartıyor ortaya. Mesela 2 crude'den bir tane şeyden, 2 crude birden, 2 tane petrol birden, bir tane petrol 3'ten karıştırsan 24 artı 8, 32, 32 bölü 3, 10,66'lık oktanın olmuş oluyor gibi. Alright? Any other questions? Alright, then let's keep going. What is my decision variable then? I've already given you a hint over here actually. What's my decision variable?
IJK diye bir şey tanımlarsak oktan değerini için bir variable atayabilir miyiz?
Oktan için variable atamana gerek yok. Oktanı çünkü sen constant olarak kullanabilirsin. Okay, octane rating and sulfur content, they are obviously constants over here because at most 1%, at least 10, these type of expressions, at least at most, they are most widely used for constraints. There may be of course exceptions. Exceptions are abound every time, but still in here they are surely for constraints. Okay. Most of the time they are for constraints. You can understand as you model more and more stuff, but still these are for constraints. But going with indices is the right idea. Xij, not K though. You don't need K yet. Xij. But what are my indices? Inj. Let's start there. Xij.
Hocam crude
Gas.
type'la evet ben onu diyecektim. Gas type diyecektim.
Güzel. Petrol ve benzin. I is for the crude oil. J is for the gas. Okay. Using I barrels of crude oil to produce gas J. Again, the same amount of barrels. Because there is no loss in volume, I think, right? I don't remember reading something about loss of volume. By the way, be very careful with this one because it's possible. You may lose volume during conversion, okay? From petrol to gas, for example. From oil to gas, you may lose volume, but it doesn't say that over here. Yani şunu demek istiyorum. Bazı sorularda hacim kaybı olabilir. Der ki bununla alakalı soru vardı, burada yok. Bayağıdır da örneği koymadım. Bir ara koyayım, onu da anlatayım size. Güzel olur. Üretim yaptığınız ham maddenin toplam ağırlığı, işte hacmi vesairesi azalabilir son product'a geçerken. Onun da şeyleri var. Dikkat edilmesi gereken noktaları var. Güzel oldu bunu hatırlamam. Onunla alakalı bir tane örneğim vardı. Onu koyarım sonra, anlatırım onu da. Still, we have to be careful. There is no loss in volume over here. We're not losing barrels. It doesn't like that, right? Anything like that over here. But still, you may lose volume. You have to act accordingly if that happens. But still, Xij, perfect. Number of I is the number of barrels used, as in the oil, to produce the jade, gas. So Xij, perfect. What else? We have more decision variables. This was the linchpin. This was the most important decision variable, but we have at least one other decision variable.
Advertising?
Yes, advertising, perfect. Number of, amount of money we're going to use to advertise oil J. It's for oils only. So the advertising is going to be dependent on the index J. Let's call it AJ. Okay, AJ is the number of the amount of money we spend to advertise oil J. Okay, and of course we have the demand, and stuff like that. So we can of course give a number for sulfur percentage maybe, or octane rating maybe, but we will see if we need them or not in a second. Okay, now I don't think we will, but we can name them anyway. So we have to find our constraints. What constraints do I have? Okay, I have found the decision variables. Xij, number of barrels I'm using from oil type to produce gas type. Perfect. And we have the advertisement. Perfect. What are my constraints now? Okay, first of all, we have the raw material constraint, we have the demand constraint, we have the production capacity constraint. What else?
What about the sulfur content?
Sulfur and octane constraints as
Octane
well. They have to be there as well. Yeah. Okay. How can I write them? How can I write those though? Any ideas? Okay, let's start with the easy ones. Let's start with the obvious ones. For example, we have a demand for each, oil. Think of the first oil. How many barrels do I have for demand for the first oil? First gas, not oil. For the first gas.
3,000.
3,000 barrels, right? So for A1 is the advertisement spent for the first oil, right? For A1, for each dollar of advertisement I use, I will get what? 20 more barrels, right? So actually my demand is 3,000 plus what?
I times 20.
Yeah. 10, right? I will get 10. Yeah, 10 barrels. 10 times AI, not 20. 20 was the money spent here. So
Yes.
10 times A1, right? So I actually have 3,000 plus 10 times A1. This is my demand for the first oil. First gas, sorry. Keep confusing them myself, but still. The first J. I never use the names. I just use the indices because it's easier to remember most of the time. So yeah. Because I keep mixing oil and gas in my head all the time. It happens. It's perfect normal. You're going to do this too, but if you start just working with indices, you're going to be fine because indices are always the same in your head. It doesn't really change that much. So I have 10 times AJ plus A1 plus 3,000 for the first one. So what about this? This is my demand, but how do I meet this demand? What do I need to meet this demand? How can I meet that demand? Remember Xij? What was Xij? I is the number of the barrels of gas used to produce I was the barrels of oil used to produce gas J. J is 1 because we are talking about the first one. So everything in total I'm going to sum every I value for j is equal to 1. So summing xij where j is equal to 1 is going to give me the total number of first gas I have manufactured, right? Let's take a look over here. This one. By the way, we have other constants. We're going to talk about them in a second, but this over here is the demand, okay? We are producing everything over here, okay? This is my demand, and this is the amount produced. So this should be equal, it says. It doesn't have to be equal, right? I can write it greater than or lesser than. Which one is allowed here? Is it greater than or lesser than? Which one is allowed here? It can be equal. Equal is fine, by the way, but which one is allowed? Greater than or lesser than?
Greater than.
Greater than. Why? Because the demand has to be met. It says that you have to meet your demand, okay? You have to meet your demand, so greater than is allowed over here, okay? You cannot write less than. Equal is fine, because you're gonna just use your advertisement to meet that anyway, but you can write greater than. You can produce more than your demand, but you cannot produce less than your demand. But you wouldn't produce more than your demand. We already know that one, but you can if you want to, okay? But as you're gonna maximize your profit, you will not produce more than your demand, but you could have. You have the option to do that if you want to. So writing greater than or equal to is okay over here. Raw material, I know that the raw material is at most 5,000 for all for all raw materials, for all oil, let's say, crude oil. So it's 5,000 at most. Whatever I use to produce, I'm gonna order 5,000 at most. And this is my production capacity, 14,000 barrels, everything over here. And this is the objective function. Now, I'm missing something very important. I'm missing the octane rating and sulfur content. So how can I write this? This is the most important part in this question. The blending this is the heart of the blending part. How can I write these? What do I need?
Kesirli bir şekilde yazabilir miyiz mesela? Fractions.
Yes, you can use fractions, exactly. Yeah, how can I write these?
I use like 12 times x11 if I is the type of crude oil, and the second one, J, is for type of oil, gas, and
Okay.
12 times x11 plus 6 times x21 plus 8 times x31 divided by the total of xyj, and we add up all of the i's. It's bigger than 10.
Plus 8 times x31. Okay, let me just write this so everyone can keep up. Which is divided by the total of x11 plus x21 plus x31, right?
For gas 1, I guess.
For gas 1.
For octane only.
Yeah, for octane only. Which was for gas 1, 10, right?
Yes, maybe it could be correct. I don't know.
It can be greater than or equal to. It's okay. Both of them work. This is so, big though, but still okay. Now it's going down, but still. As you can see, this one over here, this 10 comes from here. At least 10 octane rating, okay? Octane rating of at least 10 for gas 1 only. So as it's for gas 1 only, the gas part is stable. It's the same always, but the oil part is changing. So 12 times, well, how many barrels of oil I have used for the first oil? 6 times the number of barrels oil 2, and 8 times number of barrels oil 3. This is the total number of barrels I have used. So I'm just taking over here this one. This is the total number of octane rating I have divided by the total number of barrels. I'm just taking a weighted average over here. That's all I'm doing, okay? This is just a weighted average. This weighted average should be greater than or equal to 10. I'm going to do this for every octane rating and every sulfur content for each of, oil types, gas types, sorry. I will have not that much, but still 6 different, constraints over here as well. So 6 constraints, 2 for each gas, 1 octane rating and 1 sulfur content, and plus all the, let me just go there. All the constraints I have written over here. So I have how many constraints over here? 3, another 3 here, 6, 6 plus 6, 12. And I have, how many constraints do I have here? Production capacity constraint. These two are easy. 3 plus 3. But how many constraints do I have here?
9.
Just one. Only one.
Mhm.
That's it. Because you are summing everything. You don't have any indices left. So it's just one constraint. So 6
yes.
plus 3 plus 3 plus 1. 13 constraints. Okay?
And when we have ij next to the sum
Yes.
sign.
You are summing all ij. So there's just one thing coming out of here, which is going to be less than 14,000. All right? Any questions up until now? Okay, then. So the next problem we're going to see is an old exam problem, actually. We have asked this before, and it has even been asked in other exams, not just operations research, but in different types of exams as well. Now, what we have here is a dentist problem. So Miss Ruth runs a dental health clinic. Her daily schedule is fluid and can change depending on the number of patients she has to see for a routine visit, the number of operations she has to perform, the number of managerial tasks she has to undertake, and whether or not recruiting a new dentist. She currently has 5 dentists working for her who can see patients for routine visits or perform operations. So there are actually managerial tasks that only Miss Ruth can perform, and there are dentistry tasks that her other dentists, her workers, can perform for her as well. Seeing patients during a routine visit usually takes about 30 minutes each. Root canal operations can take longer and on average last 2 hours. Managerial tasks can be done in 15 minutes. They can also be skipped, but that costs the clinic $100 per task. Recruiting a new dentist takes a whole day of interviews where Ms. Root can't perform any other tasks. And the new dentist starts on the next workday. Experienced dentists are paid $200 daily. It's a lot of money. Ms. Ruth's clinic is extremely popular and its demands is presumed to be unlimited. If she and her dentist work 10 hours a day, formulate a linear programming model that maximizes their total profit at the end of 30 work days. So, as you can see, we have 2 types of workers, Ms. Ruth herself and her dentists. And there's the amount of money we make, the profit table, as you can see here. And it's not the income, it's the profit itself. And there is the demand. So there are some demands for some tasks. Normally the demand for routine stuff is unlimited, okay, but still there are 15 operations in 30 days and 2 managerial tasks per day for a total of 60. So you can skip managerial tasks, but it will cost you. There's a penalty for that one as well. Now, we are trying to maximize profit, so it's a maximization problem. All right, but we have to find our decision variables as well. What are our decision variables? There'll be a few of them. So, any ideas? What are our decision variables?
Dentist number on the clinic, in the clinic.
Okay, number of dentists we have. All right, what else?
Number of managerial tasks.
Number of managerial tasks, maybe. Number of skip managerial tasks. Okay, yeah, maybe. What else?
Number of new dentists.
Number of new dentists. Okay, recruited number. Nice, smart. All right. The recruited number, by the way, is something you can use to find out the number of dentists you have, because you only have 5 dentists. So if you add 5 more, you will have 10. So they are related. It's okay going both ways. Actually, in my mind, recruitment is better than having the number of dentists because you can just keep adding and adding and adding. It's easier that way. But still, they can both work. No problems there. You actually have to try to at least find the number of visitations in a day, okay? The routine visits, okay? Number of operations in a day. These are important stuff because they have to be met, okay? But who are doing these? For example, I can say that number of visitations in day T by Miss Ruth or by the dentists. There are 2 different stuff, okay? Because depending on the number of visitations done by Miss Ruth, the rest will be done by the dentist, and this is something you have to figure out because you're trying to make money out of them. But with operations, you have to find the operations because they will be in total 15 of them per day. So they are limited. Okay, you have to find the number of operations Miss Ruth performs and number of operations the dentist perform in the day, because it will be limited. And we of course have managerial tasks in a day, 2 per day, so you have to take care of them as well. And if you skip those managerial tasks, you cannot do them later on, so it has to be done in that day anyway. So you actually have, when you think about it, at least in my perspective, as I said, you can find a different solution as long as it works, it's logical, it's okay. These are our decision variables. Number of visitations in day t, which is ti, by Miss Ruth when I is equal to 1, or the dentist when I is equal to 2. So we are trying to find the number of visitations per day. And number of operations per day, same, by Miss Ruth when I is equal to 1, or by dentist when I is equal to 2. And number of managerial tasks in a day by Miss Ruth, because dentists cannot make managerial tasks. It has to be 1. I should be 1. You can just skip I and write MT here as well. But for clearness purposes, let's say, for object, being extremely clear, I'm just writing here 1, so we know that this is done by Miss Ruth. And recruitment parameter, of course, recruitment variable. If there's recruitment going on, Miss Ruth is doing it, and it takes a whole day. Now, these are our, let's say, decision variables, starting decision variables. We may add stuff or subtract stuff going on the way, but still, these are our decision variables. Now, we have to find the constraints and the objective function. As I mentioned earlier, you can start with the objective function or the constraints, depending on your style or how you are feeling about that question. Okay, I usually start with the constraints and then go to the objective function. So I will skip this part and go straight to constraints and talk about them. Now, first things first, we know that we have, let's see here, where is it? Yeah, over here, 2 per day. Managerial tasks are 2 per day. So we are gonna take managerial tasks per day is less than 2. So we can do no managerial tasks at all, but they cost us. But we can, do 2 of them at once for all t, for every day. So there is 30 rows of constraints just here, 30 constraints only here. Okay, because from day 1 to day 30. And over here, recruitment. Is Miss Ruth going to recruit? Okay, RT is either 1 or 0. If you are going to recruit, you're going to recruit 1 new dentist. If not, it's 0. And these are number of operations. Now, we are going to sum on I, TI, and that's a total of 15. Now, take a look over here. Total number of operations. You can just schedule them however you want, okay? The T days, the days of operations can change, but you can schedule them however you want, 15 operations in 30 days. So I'm going to schedule them however I want. So I'm going to sum all the T's and all the I's. I don't know who's going to do it, the dentist or the Miss Ruth. So the total number of operations should be at most 15, can be at most 15. Maybe I will have less operations in those 30 days to make more money from routine visitations, for example. We don't know yet. These are not must. If it was must, it would be equal. If you had written equal, it would be okay as well. It doesn't really matter, but it's not a must right now. It's something you have to, schedule if you need it or not. Now, these 2 constraints, these are the most important ones. These are how Miss Ruth and the dentist can allocate their times. Okay, what will they be doing on each day? Now, think about it. They have 10 hours only per day. So each day, for Miss Ruth at least, you can spend 10 hours. And these 10 hours can be divided between time we have spent doing our, all our tasks. Managerial tasks. It says that managerial task takes only 15 minutes. So it's 1 over 4 hours. Okay, 0.245 hour per managerial task. Plus, recruitment takes all day, 10 hours. So if I'm recruiting someone, if this value is 1, then it's 10 hours. And then there's the visitations. It takes only half an hour, 30 minutes. So 0.5 times visitation number, plus operations, which take 2 hours. So 2 times number of operations. This is how Miss Ruth can allocate her time. All right. And this is how dentists can allocate their time for all the days. Now, let's go back. We have a total of 30 days, right? Yeah. And each of them have 10 hours. So we will have over here, this is 30 days, not 60 days. 30 days dentist plus constraint. Over here, we start with 150. Why do we start with 150? What is this 150? Let's start with this question. This 150 is the total number of hours we have available for 5 dentists. Okay, so let's start with that one. This is actually 110. No, this should be 1,500. And so think about it. You have 30 days. Okay, 30 work days times 10 hours, 300 hours times 5 dentists. So it should be 1,500. There's a zero missing over here. 1,500. This is the baseline. Okay, this is how we are gonna start. And then as we recruit people, we're gonna gain hours by them. Now, this part is the recruitment part. For example, if I recruit someone on the first day, he or she will work for 29 days. Can you see that? If you recruit it for on the first day they will not be working. Interviews will take all day, and you will decide who to hire at the end of that day, and that person will start the next day. Is it within the question as well? So he or she will work for 29 days after being recruited. So it should be 10 minus T. T is the recruitment day over here. So for each T, if there's a recruitment, if this value is 1, you are working for this many days. Okay, if this value is 1, 30 minus T days times 10 hours. This is the amount of hours added to my 1,500 hours of work I have available from 5 dentists. Okay, so these are our total number of hours we have. These are total number of hours we have, and these are the operations they can perform: visitations or operations. Their total number should be for each T, of course, summed and calculated. So we can see how many hours we have, how many how we can allocate our dentist to work. Okay, from here. So these two are our time allocation for Miss Ruth and for the dentist. Then when we go back to the maximization problem, we are trying to maximize our profit. So we have to calculate that profit. As you can see, there are profits over here. For example, for Miss Ruth is 750, for the dentist is 500 per operation, and for visitation, $150 for routine visit and $50 for routine visit for the dentist. So we have to use these. All right, just go back and use them now. This is for Miss Ruth. As you can see, this is 750 times operation by Miss Ruth. 500 times operation by the dentist. All right, no problems over here yet. 150 times visitations by Miss Ruth. All right, 550 times visitations by dentist. These are our profits. Perfect. Now coming over here. These values are our penalties for missing managerial tasks. So if I miss any managerial tasks, which are a total of 60 of them, if I miss anything, so this one will just give me the number of managerial tasks I have missed. Because as long as I'm doing managerial tasks, as long as these values are 1, this total is going to be 60, which will give me 0. If I do every managerial task available, 60 of them, this will be 0, so no penalties there. But if I miss some of them, this value can be anything, 1 to 60, whatever, and I have to pay that much money as a penalty. And over here, these are my wages that I pay to the dentist. This is per dentist, 200 per day, and I have a total of 30 days times 5 dentists at the start. This is the number of dentists times the number of days I have available at the start, okay, initial stage. And then I'm recruiting people, so I have to recruit these as well. And I'm gonna pay them for each day they work, which is 30 minus T. So if I'm recruiting someone in day 1, I'm gonna pay that person 29 times 200. If I recruit someone on day 10, I'm gonna pay them 20 times 200, all right? So this is the wages part. These are the initial doctors that I have, dentists that I have, and these are the dentists I have recruited. So this total is going to be my profit. Now, this model looks extremely complex, I know, but when you get into it, when you dismantle it and work it part by part, you will understand it perfectly. Don't worry about it, and we can go over it later on, of course. These are all the different types of models. You can see there are lots of other types of models you can see, and you can find examples of them in the book or in Google, for example, sometimes. But just work on the book. The book is the most important source for you about modeling, at least. And from there, we get to irregularities. Now, we know that we have to model stuff linearly, okay? And this means that we have to find linear stuff to model, but there are sometimes irregularities. For example, absolute values, right? Absolute value is not linear because we know that it makes a V shape, right? For example, absolute value of x, it makes a V shape, comes down and goes up. This is not linear. It's partitioned. It has to be dealt differently. But we can make some adjustments to turn absolute value into a linear model. Not always, because you can have x squares in absolute values as well. But if the inside part, the part inside the absolute value is linear, you can turn it into a linear problem as well, as long as it's in the objective function at least. So how can we do this? Okay, let's just assume that there is an fx, and we are talking about the absolute value of that fx, that function, which is equal to lambda value. Doesn't really matter. So we know that if this is like this, if we know that fx is equal to lambda, then we know that both fx or minus fx, one of them is the maximized value, bigger value, because if fx is minus 10, then it's 10. If it's 10, it's 10 again. If it's minus 8, it's 8. So one of them, either the function itself or the negative value of that function, is the bigger value. So one of them is going to be equal to lambda. So lambda will be an upper limit for both of them, because one of them will be lambda, other one will be minus lambda. Lambda is always a positive value because it's the it comes from the equation absolute value, so it's always a positive value or 0. But still, lambda is going to be the upper limit for both of these functions. So we can just say that fx is less than lambda or minus fx is less than lambda. Now, we can use this to minimize this absolute value. This is important. You cannot maximize absolute value, because when you maximize it, you have to go up, and absolute value can go infinitely up, okay? As long as you don't constrain it, it can go up infinitely. But when you want to minimize absolute value, it can only be at most 0. You cannot go lower than 0 with absolute value. So minimizing works over here. So we have to minimize lambda we are talking about. Of course, you can maximize. There can be other options, but still focus on minimizing right now. We want to minimize lambda. So we are either minimizing this fx value or minus fx value. One of them is going to be minimized. The other one will be maximized when you are minimizing them. Why? Think of it like this. Let's just go to the drawing board and start with that one. For example, let's draw. Now, over here, let's say this is 0, the middle point. Now, you have, let's say, fx over here somewhere, and minus fx over here somewhere. Again, these are symmetrical. So if x is over here, then minus fx over here. Let's just draw them. If it's over here, then this one is over here. It doesn't really, my drawing is too bad, but yeah, you can bear with it. So this is fx, this is minus fx. If you are minimizing fx, it means that it's getting closer and closer to 0, right? You are trying to minimize fx value. Then you are maximizing minus fx, because it is getting closer and closer to 0 as well, because they're symmetrical. Okay, one of them is the right-hand side of 0, one of them is on the left-hand side of 0, but they are symmetrical. So when you are minimizing one of them, you're actually maximizing the other one. So you are doing both of them at the same time. So we are minimizing one of them, which maximizes the other one, but which also minimizes the lambda value. Okay, as long as the lambda value is minimized, we are doing what we want to do. So we are gonna try and find out how we can do this. We are trying to minimize x minus 3, absolute value of x minus 3, for example. You already know this. You can answer this from your head. It's very easy to do that. But there is a catch over here. It's not going to be that easy all the time. So what you need to do is just find a value where you can minimize everything over here. So to do that, you have to get the x minus 3 value, and you have to formulate a model that can minimize the absolute value. All right, we said that instead of writing the fx value, we can just write the lambda value. So to do that, we will just change that fx, which is x minus 3, into two parts, the x minus 3 and the 3 minus x, the way we do it with the absolute value normally. So fx is going to be less than lambda, and minus fx, which is 3 minus x right now, is going to be less than lambda as well. Now, we are going to minimize lambda instead of minimizing this x minus 3. This will minimize all the possible values for that absolute value, so that we can say that we have minimized x minus 3, absolute value of x minus 3. For example, let's take a look. The plant layout problem. Now it says that consider the problem of locating a new machine to an existing layout consisting of 4 machines. We have 4 machines and we are going to put a new machine. These machines are located at the following coordinates in 2-dimensional space. 3 to 1, 0 to -3, -2 to 2, 1 to 4. Use Manhattan distance to calculate the distances between machines. Now, Manhattan distance, not Euclidean distance. Do you know what Manhattan distance is? Do you remember? Anyone knows what Manhattan distance is? This is also a math problem as much as it's an optimization problem. Manhattan distance, how does it work?
Hocam 90 derecelik böyle dümdüz çizgiler değil miydi o?
Güzel. Euclidean distance dediğimiz şeyde de hipotenüse bakıyorduk. Burada sadece üçgenin kenarlarını topluyoruz aslında. Kenarlarının şeylerine bakıyoruz aslında. Alright. With Euclidean distance, we are taking a look at the hypotenuse, but here we are just gonna sum the length of the edges. So use Manhattan distance to calculate the distance between machines. So for example, with these 2 machines, what's the Manhattan distance between these 2 machines? Can you see that?
5 mi acaba?
The Manhattan distance between these two should be 7. 3 minus 0, 1 minus -3.
Ah.
3 plus 4, 7. Or these two, -2 to 1, it's 3. This is 2. This is 5, for example. So you have to, take the, let's say, difference between these 2 values all the time. So if this is an x value, let's call this x value and let's call this the y value. The difference between x values and the difference between y values. So it's going to be equal to the absolute value of those differences. So what we want to do is just minimize the d values, okay, the distances between dij. So xi is the coordinates of the new machine, yij the coordinates of the machine j, and dij distance of coordinate of I of new machine to machine j. So we are trying to find the distance between those 2 machines. For example, x1 and x2 are going to be the location of the new machine. y11 and y21 are going to be the coordinates for machine 1, which we already know over here, 3 to 1. So y11 is this one, 3, y21 is this one, 1. And now we are going to find all the y values, of course, from here. We can write them. It's easy. And dij is going to be the difference between xi and yi. So we can write it like this. We are trying to minimize the total distance over here. And total distance can be written like this one. xi minus xij for all ij. Of course, we're going to check for everything. So xi is always the same. The position we are putting that new machine, the location, the coordinates. And yij are, there already, we already know their values. We will just use these values. They are not variables, okay? xi is the only variable over here. These are parameters. We already know their values. So we have to minimize this one, which means that we will try to minimize some sort of lambda value, which is going to be, derived from this absolute value. So we just call it delta instead of lambda now. We are trying to minimize the total delta ij, where delta ij is greater than xi minus yij or greater than yij minus xi. For everything, you're going to sum all of them, okay, for all 4 machines. So the absolute value just adds new constraints to your, current model. If you had more, let's say constraints over here, those constraints wouldn't change. For example, if the question said that, okay, the new machine can only be, for example, we can only put the new machine, or the machine can only be located in the positive quadrants, where x values can only have positive, values. You would just write over here, xi is greater than or equal to 0, or greater than 0, if there are no 0 values allowed. So you would just be writing a constraint over here, and that constraint would just carry over here, okay? We will be using the same constraint. These 2 constraints are added for the absolute value only. That's all. And another irregularity, the URS variables. Now, when you have URS variables, what is a URS variable? URS means unrestricted sign, okay? As I said earlier, the last week at least, we have a sign restriction. We always assume our decision variables are non-negative, 0 or positive. But they can be negative as well. There can be negative values as well. And if they are always negative, you just multiply it by -1 and turn them into positive values. That's easy. But if they can be both positive and negative at the same time, then they become unrestricted sign variables, which means that you have to take into consideration how they can be turned into positive variables, because you have to find a way to turn them into positive variables to be able to solve the problem. That's how the modeling part works. So we will just take those URS variables, unrestricted sign variables, and turn them into two variables per unrestricted sign variable. Why? For example, x1, think of x1. If x1 was 5, okay, you could just write it as 5. But if x1 was -5, you would have to find a way to write it as 5 once again, so that you would have positive values. Okay, let's just start with a drawing over here. I'm just trying to draw this. I think I need 3 lines, right? Yes, if I remember correctly. Let's just assume that we are trying to find oh boy, I don't think I'm gonna fit my text in here, but we'll see. So let's assume that this is x1 and this is x1, and you can have the x1 value over here as well. Now, x1 is equal to this one, x1 dash minus x1 double dash. So we are trying to find this value from these two values. We will start from here, of course. If x1 is -5, for example, or -2, start with a simpler one. Now, to get -2, you have to find two positive variables over here, two positive values for these two variables over here to find -2. For example, you can write 1 and 3. 1 minus 3 is -2. You can write 0 and 2. 0 minus 2 is -2. You can write 3 and 4. 3 minus 5, 3 and 5. 3 minus 5 is -2, and etc. So you can just write anything that's has a difference of 2 in the right order to get -2, which would mean that you would have to create some sort of new values over here, for example 1 and 3, to be able to get to this 2. Now, the thing is, which you will learn later on, not here, but there's only one solution, one correct solution, which is 0 and 2. But we will see why this is like this in the later stages of the course anyway. So 0 and 2 is the only part you can write, only solution you can write for -2, but still this solution exists. They are non-negative and they can be used to find the -2 whenever you need it. And you can use, for example, for +3, 3 and 0 to get +3. So x1 can have any type of sign, either minus or plus, and you can find variables, other two variables, to find that sign value, okay? So this is how we deal with the URS variables. We can have unrestricted sign variables, okay? But we just divide them into two new variables and just have those variables get, positive values, non-negative values. Another irregularity, which is a bit harder than the rest, I would say, are the piecewise linearity. Now, piecewise linearity, when you take a look at this, graph, this graph is not linear, but it is piecewise linear. This piece is linear itself. This piece is linear, this is linear, and this is linear as well. But the graph itself, or as you can see, this piecewise linear function itself is not linear, but it consists of linear lines, okay? Linear lines, straight lines. These are all linear stuff. We can change this function into a linear function, okay? To do that, we have two different methods. Both of them are in the book, and I strongly urge you to take a look at them after even I show you here, because this part is usually not understood very well. And we will see how that works anyways in the example after this slide, but still you have to make sure that you solve other problems like this one, because this part is one of the hardest parts in the first 2 weeks that you're going to see, except from the modeling itself. Modeling itself is pretty hard as well, but still. We have two different modeling tricks, let's say, we use for modeling this one. In the first one, we use the slopes and the p-slants. In the second one, we use the y values and critical x values, but they don't change. They always give us the same thing. For example, using slopes and p-slants. we are actually trying to minimize this fx. We have some constraints. We don't know about them. We don't need them right now, but we are trying to minimize something over here. And to do that, we are trying to find the lowest y values. Okay, fx will be the total of these values. Why? Because you're gonna get some y values over here, and you're gonna get some. You have some slopes over here, and you're just gonna multiply them to get the x value. So, for example, if you have a value of, for example, pick a point. Let's pick 4. Okay, if I pick 4, I'm getting every part of this line, and I'm getting 2 points from this line. So when I get 4, let's check over here and see. When I get 4, I'm in here. X value, when x value is 4, I'm in here. So I'm getting 2 points from here and 2 points from here. And I will get the value, 4 minus 2 is 2, 2 times 2 is 4, and plus 2 is 6. So I will get fx is equal to 6. If I use 4 in here, I should get the same value. If I use 4, I'm using y, this is y1. I'm using 2 points from y1 and 2 points from y2, 0 from y3 and 0 from y4 anywhere. So 2, 2, 0, 0. So the x is total 4, and fx is 2 plus 2 times 2, 6. So what I am getting is the same value, 6. Why do I use like this? As I said, we are trying to minimize this actual minimization question. So we are trying to minimize the length of going up. Okay, so we use the slope, the smallest slope first. This one. If this was done differently, if the slopes were different, it wouldn't work. Okay, you have to start with the smallest slope, so it should be in the lowest part. It usually works like this. It doesn't work in any other way. And you know that these are the lengths anyway. Y values are your lengths, so y1 should be less than 2, y2 should be less than 3, etc. And in the second model, okay, this just works. We see that it's working. How it's working, just we have to analyze it to really understand. But as I said, it uses slopes and piece lengths. Okay, you are just taking this piecewise linear function and separating it into your length sizes, the lengths, and your slopes. And these values use the y values and critical x values. Okay, critical x values are 0, 2, 5, 7, 10. You can see them over here as well. 0, 2, 5, 7, 10. These are your critical x values. And your y values compared to these, of course, values will be 0, 2, 8, 16, and 40. And you can see them here. 0, 4, 8, 16, 40, etc. So 8, 16, 40. You can find these values using those critical values on the map anyway. Now, you can use those as a total of your fx, and this will give you which part of which z you are at. How many, let's say, which part of z you are in. For example, think about like this. We are actually trying to break this into pieces and trying to figure out which piece we are using right now. So, for example, we can be at z5 is equal to 1, which means that we are over here. But you can also be z4 is equal to 1 over 2 and z5 is equal to 1 over 2. So it will be somewhere between those two values. Okay, you are trying to find out which part, which point you are closer to. For example, if you are just in the middle over here, okay, if you are at this point, so you are 1/2 over here, 1/2 over here. But if you are closer over here, like it's just 1/3 over here, you are 2/3 over here, 1/3 over here, etc. So you are trying to find where you are here, how this is weighted, okay? And the more weight this point has, the closer you are to that point. It's like the weighted average. It's the same as the weighted average. So you are trying to figure out where you are. And to do that, you have to find between which z values you want to stay. And from there, you're going to find those z values. If you are between, for example, if you are between these 2 points, z0, z1, z2, z3, you are between z2 and z3, then other z values will not have any value assigned to them. They will be just 0. But those two will have a value assigned to them. So you are trying to figure out where you are with this one. They are both hard models, I would say, but I think I prefer this one because this is more understandable than this one, at least graphically more understandable than this one, because you are exactly doing you're just doing some weighted average trick. Okay, you are trying to find which point you are closer to. Okay, how does this work? Simple problem, a simple model. 10,000 barrels of oil will be sent from point A to point B through 2 pipelines. We have 2 pipelines. Shipment duration is rated with shipment quantity. Okay, the more you send, the longer it takes. simple. If x 1,000 barrels of oil is sent through the first pipeline, shipment duration will be x1 square hours. If x 2,000 barrels of oil is sent through the second pipeline, shipment duration will be x2 to the power of 1.5 hours. So we actually have non-linear values over here. We have to turn them into linear values. To do that, we can use piecewise, linearity. We will just separate those non-linear, graphs and make them into smaller linear graphs. And it says that formulate an LP that will minimize the shipment duration if two pipelines are used simultaneously for the oil shipment. Start by linearizing nonlinear durations. So to do this one, nonlinear durations, you have to linearize those x1 square and x1 to the power of 1.5 hour functions. So you can see over here, x1 square, we're just taking x and separating it into pieces, dividing it into pieces. You can pick the length of those pieces. Okay, it's just dividing into 4 right now. So a piece over here, a piece over here, and a piece over here, and a piece over here. So we have 4 pieces between 0 and 2.5, between 2.5 and 5, between 5 and 7.5, between 7.5 and 10. 4 pieces over here. So you can just say that, okay, I will just calculate those points. These are my critical values now. Okay, these are my critical x values, just like in here. These are my critical x values. And now I'm just gonna calculate my critical y values. These are my y values. Now, from here I can see that if I send every drop of oil from the first pipeline, it will take 100. We are just saying that it's 10. This is not 10,000, but it's 10. The thousands are omitted. 100 hours, for example. If I send all from the second pipe, it's going to take 31 hours. Now I'm trying to find the best way of doing this by minimizing the total time I'm spending, okay, the maximum time I'm spending. Now, this is a maximization problem, actually a minimization problem of the maximized value. So what I'm trying to do is find the best value to send to the first pipeline, which will define the value that I will send to the second pipeline, which will give me a maximum hour. For example, if we send everything to x1, to first one, we get 100 from here and 0 from here. So our maximized version is 100. I cannot get another value. And if I send 7.5 to the first pipe and 2.5 to the second pipe, I will get 56 hours from the first pipe and 4 hours from the second pipe. 56 is the maximized value. I'm trying to minimize this maximized value, so it's better than 100, but it's still okay. It's awesome. If I send 5 to each of them, the first one will give me 25 hours and the second one will give me 11 hours. So the maximized value is 25, which is okay, better than 56 anyway. And if I send 2.5 to the first one and 7.5 to the second one, I will get 6 and 20. 20 is better than 25, so it's better yet. If I send everything to the second one and nothing to the first one, 0 and 31. 31 is not as good as 20, so 20 is the better option. But there might be a far better option, something between those two. I don't have to send 7.5 to 20. I could have sent 7 or maybe 6.5 or 6. We don't know for those values, so we have to just model it. And we can do this both ways. So I can just pick one of them, and I pick method 2, I guess, and just model it like this. We are trying to minimize the longest shipment duration in hours, okay? And to do that, we have to say that this longest shipment hour is going to be greater than both F1 and F2. Okay, it's just like the absolute value, which makes sense. And I'm trying to minimize this lambda value. All right, for the first pipeline, I have these. Remember this one, let's go back. These are my, piecewise linearity y values, and for the first one, these are my piecewise linearity y values for the second one. For the first one and for the second one, for both of them, I have the same x values anyway. I have divided the function in the same way. So I'm just gonna put those values, okay? These are my division values for x values, and these are my y values. It's so simple when you model it like that. You don't even need to understand the background how it works. It's too easy to model it like that. And I know that if I pick two z values, their total should be 1, and none of the others should take any value. So the whole summation should be equal to 1 anyway. Same thing for the second pipeline. The z values do not change, so 0 to 25 for the x2 values, 0 to 25, 5, 7.5, and 10. All the same coefficients. Coefficients do not change, but these values will change because they have a different, they take different values from different functions. So this critical y values will change anyway. I'm going to write those y values for the second pipeline, and the total is again 1. When I write these two as constraints, I'm actually done over here. So I know that the total number of barrels I have is 10,000, so I'm just going to add x1 plus x2 is equal to 10, and all variables are greater than 0. And we are actually done over here because we are trying to minimize f1 and f2. One of them is going to minimize anyway. We are only trying to minimize lambda, and these f1 and f2 values are going to be less than or equal to lambda anyways. I know this is a bit confusing and too much at first, but trust me, when you take a look at the book and do some examples, it's going to stick. And as I said, for me at least, method 2 is easier to understand and easier to implement when compared to method 1, but they are both applicable. And probably for the first homework, you're going to have to use at least one of them. I don't know how the assistants will be, what kind of question they will be giving you, but still these are going to work for you somehow.
Hocam bir şey sorabilir miyim?
Tabii ki.
Şu en alttaki z değerlerini 1'e eşitledik ya. O kısmı anlamadım ben. O 1 ne oluyor oradaki?
Okey, hemen geri dönelim. Şuradaki 1 ile aynı şey bu z'lere eşitlediğimiz durum. Şuna bakın, tamam mı? Burada şöyle bir şey yapıyoruz. İkinci metot için konuşursak. İkinci metotta hangi piece'i kullandığımızı seçiyoruz. Biz bu piece'lerin bir tanesi biteceğiz ya. Herhangi bir noktada biteceğiz ya. Şuradaki parçalara bakın. Bu parçaların bir tanesi bize en iyi değeri verecek. Seçtiğimiz parçanın köşe noktalarını seçiyoruz, tamam mı? Yani mesela x1 ile z1 ile z2'yi seçersem birinci parça seçtim, burayı seçtim. Z2 ile Z3 seçtiysem burayı seçtim. Z3 Z4 seçtim, burayı seçtim. Z4 Z1 seçtim, burayı seçtim demek oluyor. Şuraya seçtiğimi varsayalım. Z2 ile Z3 seçtiğimi varsayalım. O zaman diyor ki Z2 ile Z3'ü ne kadar kullanıyorsun? Ağırlıklı şey yapman gerekiyor. Ağırlıklandırmış ortalama alman gerekiyor. Orada da ağırlık merkezi bulmak için Z değerlerinin kaç olduğuna bakıyorsun. Yani öyle bir Z2 ve Z3 değeri seç ki bu ikisinin ortalamasından şurada aldığın değer çıksın ortaya diyor. Bunu kullandırtıyor bize aslında. Yaptığı şey bu.
Anladım hocam. Anladım. Yüzdesel olarak ne kadar kullanıyorsun? Yüzdesel olarak ne kadar kullanıyorsun? O bir de aslında %100.
Aynen öyle. Yüzdesel olarak ne kadar kullanana bakıyorsun. Hangi Z değerinin yüzdesel olarak ne kadar kullan? Hangisi daha yakınsın? Hangi Z değeri daha büyükse ona daha yakınsın demek oluyor.
Anladım hocam. Teşekkür
Any other questions?
Hocam ama böyle yapınca 3 tane nokta seçmememiz için bir engel yok önümüzde.
Var aslında. 3 tane nokta seçemiyorsun. Seçmen yanlış sonuç çıkartıyor çünkü, merak etme.
Neden hocam? Mesela yani orada
Minimizasyon yapıyorsun ya. Minimizasyon yaparken 3. bir nokta seçerse mesela bunu ve bunu alırsan 3. noktaya girmeden şu ikisinin yeteceği durumda yani. Şurada olacaksa senin cevabın. Bak cevaptan düşün. Senin cevabın buradaysa şu noktayı kullanmazsın zaten. Bu ikisinden sonuç çıkartabilirsin ya. Cevabın buradayken şu noktayı kullanırsan daha kötü bir cevaba götürebilir seni. Yanlış bir şey çıkartabilir seni. O yüzden o değeri otomatik olarak seçtirmiyor sana sorunun şeyi. Yani çözerken algoritma öyle 3. yüzüne otomatik olarak atlıyor zaten. Ona bakmıyor bile. Hep ikili sonuç çıkartabiliyor sana. Üçlü sonuç çıkardığı zaman yanlış oluyor sonuç ve bunu biliyor. Onu anlayabiliyor.
Tamam hocam, anladım. Hocam bir de bir şey sorabilir miyim? Bu son çözdüğümüz soruda model 1'i nasıl kullanacağız? Sonuçta seçtiğimiz parçaların lineer bir eğimi yok.
Evet, şunlar hep eğimlerle kurulmuş şeyi. Bunu yazdığı zaman mesela bak şu soru için, tamam mı? Bak eğimler şurada belli. 1, 2, 4, 8 değil mi? 1, 2, 4, 8'i alıp burada yeni yazıyorsun. 1, 2, 4, 8 olarak da. Şey zaten bu sabit. Y'lerin toplamı x olacak diyor. Ve y'lerin boylarına bakıyorsun. Şurası y1'in boyu, burası y2'nin boyu, burası y3'ün boyu, burası y4'ün boyu. Burada şeylerin, parçaların boylarını ve şeylerini kullanıyorsun. Eğimlerini. Burada parçaların y ve x değerlerini kullanıyorsun. Yani her ikisini de parçaya bölüyorsun aslında. Birinde parçanın eğimlerini ve parça boylarını, birinde parçaların y ve x değerlerini kullanmış olsun. Ama yaptığın şey aslında parçalara ayırmak. Burada yaptığı şey bu aslında.
Hocam aslında ben son çözdüğümüz soru için sormuştum. Mesela x1'in karesi diyor ya. Seçtiğimiz hiçbir parça için doğrusal bir eğim yok.
Değerlerini 0, 2,5, 5, 7,5, 10 diye biz kendimiz seçerek başlıyoruz. Böyle olsun diyoruz. Bunlar böyle olsun demek yerine 0, 1, 2, 3, 4, 5, 6, 8, 10 da yapabilirsiniz. Siz elinizdeki nonlinear fonksiyonu ne kadar lineerleştirmek istiyorsunuz ona karar veriyorsunuz. Burada mesela 4 parçayla lineerleştirin ben demiş. Birazcık hataya izin verin demiş. Yok ben hata olmasını istiyorum deyip 100 parçaya da bölebilirsiniz bunu. Minimum hata olsun. Çok yakında çıkayım cevabın diyebilirsiniz. Bu örnek soru olduğu için 4 parçayla yetinmiş. 10 parçaya bölebilirsiniz. Hani biraz hata olsun sıkıntı yok. Çok hata olsun dert değil demiş. Bu da 4 parçaya bölmüş sadece. Bu tamamen sizin elinizde. Size soruda şöyle bölün demiyorsa kaç parçaya böleceğiniz bir tarafta matematiksel zorluğuna bakıp ne kadar uzun sürer bunun hesaplaması deyip bir tarafta da hani bunu acaba ne kadar yakın bir cevap çıkarmak istiyorum, ne kadar gerçeğe yakın bir cevap çıkarmak istiyorumun cevabını vermeniz gerekiyor boyutunu seçerken. Bunları seçtiğiniz zaman, şurayı seçtiğiniz zaman zaten şu değerlerin hepsi otomatik çıkartıyoruz. Çünkü 0'ı yerine koy 0, 2,5'u yerine koy 6,25, 5'i yerine koy 25, işte 5'i yerine koy 11, 18 diye direkt cevaplar geliyor zaten burada. Orada bir sıkıntı olmuyor. Sonra bunları alıp şu metod 2'de olduğu gibi yerine yerleştiriyorsunuz veya metot 1'de yapacaksınız metot 1'deki gibi ama metot 1 için birazcık daha sizi zorlayacaktır. Çünkü bu değerler çıktıktan sonra bir de bu değerlerin tek tek eğimlerini bulmanız lazım noktalardan. Hani şuraya baktığınız zaman eğim bulmak ve uzunluk bulmak, uzunluk kolay 2,5 hepsi uzunluğu zaten de eğim bulmak yani nasıl ki falan belirtebilir size. Biraz daha uğraştırabilir. O yüzden bunu direkt metod 2'ye koymak yani model 2'de kullanmak çok daha kolay aslında. Çünkü tek tek eğimleri bulmak birazcık zorlayacaktır size. Yani zorlamayacaktır aslında. Uzun sürecektir sadece. Bilgisayar anında bulur bunu zaten. Siz de oturup yazıp bulabilirsiniz. Eğim bulmak zor bir şey ama uzun sürecektir. Çünkü ne yapacaksınız? İşte 0'a 0, 2,5'a 6,25 buradan eğim bulacağım. 2,5'a 6,25, 5'e 25 buradan eğim bulacağım. 5'e 25, 7,5'a 56 buradan eğim bulacağım. Ve tek tek bütün aralıkların eğimlerini bulmanız gerekiyor. Uzun sürebilecek bir şey. Burada güzel. Şimdi her y değeri bir piece. Hangi piece'i seçiyorsunuz ona karar veriyorsunuz aslında. Hangi piece'te bitireceğinize karar veriyorsunuz aslında. Ve o piece'in alabileceği bir uzunluk var. Her piece'ten ne kadar uzun seçtiğinize karar veriyorsunuz. Yani bir piece'ten bir parça, öbür piece'ten bir parça gibi bir şey yapmış oluyorsunuz aslında. Ona göre de değerlerini çıkartıyorsunuz. Şurası ise direkt olarak seçtiğiniz şey olmuş oluyor. Kritik nokta olmuş oluyor. Kritik noktalara karar veriyorsunuz. Hangi kritik noktaya ne kadar yakınım? Seçtiğiniz z değerine göre hangi kritik noktaya ne kadar yakın olduğunuza karar vermeye çalışıyorsunuz. O kritik noktanın ağırlığını seçmiş oluyorsunuz aslında. O yüzden model 2'yi anlamak daha kolay diyorum her zaman. Bence uygulaması da daha kolay, anlaması da daha kolay. Okey miyiz? Shomaki, I don't know how to pronounce your name by the way. Is it okay? Did you get the Turkish version or should I explain in English once again? Sum of all z values is equal to 1.
That would be great if you would explain it in English.
Okay. Think about it like this. In the second model, you are picking the critical part, okay? You have your critical parts over here. This is a critical point. This is another critical point, another critical point, another one, and another one. Out of these 5 critical points, you have to pick 2 of them, just 2 of them. And when you pick those 2, you have to give them weights. So any value between those 2, for example, I picked those 2 critical values, and any value between those 2 can be expressed in terms of these 2 critical points, right? And these 2 critical points form one line, a linear line. So I pick 2 critical points and I give them 2 weights, okay? And I will just find the point between them using those weights. So I have to make sure that their total is 1. When I pick 2 points, all the other points will have a weight of 0. So they will be 0, 0, 0. And I'm taking a weighted average between those 2. So they have to, their weight should be equal to 1 to be able to give me a weighted average. So all the values should equal to, sum of all the z values should equal to 1. Because I'm picking 2 of them and I'm just giving them a weighted average function, putting them in a weighted average function, which means that their total coefficient total should be 1 anyways. All right? Any other questions?